Good morning, everybody. Today we are going to solve the practice problem 3.7 from Alexander Sadiku's Fundamentals of Electric Circuit. So, if you look into this problem, here we are asked to solve this problem using mesh analysis. And we have to find out I1, I2 and I3 currents. And here we have three loops. Loop number 1 in which current I1 is flowing, loop number 2 in which current I2 is flowing, and loop number 3 in which current I3 is flowing. But if you look into this particular branch, which is common to both loop 1 and 2, which contains the current source 4 amps, so this particular branch can be ignored while you are using this mesh analysis. So this is a special case which is to be considered as super mesh analysis. Okay. So now we have to ignore this particular branch which consists of this 4 amps current source, and we form a new mesh called super mesh, and KVL is to be applied to this super mesh which consists of the currents I1 and I2. So now we are going to apply this KVL. So when you apply KVL, we get this as minus 8 plus 2I1 minus 2I3 plus 4I2 minus 4I3 plus 8I2 equal to 0. So rearranging this, we get this as 2I1 plus 12I2 minus 6I3 equal to 8. Dividing this by 2, we get it as I1 plus 6I2 minus 3I3, that is equal to 4. Now this becomes equation number 1. So now we are going to apply KVL to loop 3. So it is 2I3 plus 4I3 minus 4I2 plus 2I3 minus 2I1, that is equal to 0. So rearranging the terms in order, so it is minus 2I1 minus 4I2 plus 8I3 equal to 0. So dividing this equation by 2, we get it as minus I1 minus 2I2 plus 4I3 equal to 0. So now this is your equation number 2. So now we are going to apply KCL to this particular branch node, which we have already ignored. Okay. So either you can apply the nodal analysis for this branch at node Q, or you can apply this KCL to node P. Okay. So now we'll consider this Q node. So in this Q node, I1 current is leaving and I2 and 4 amp currents are entering. So the equation is leaving current I1 is equal to sum of the entering currents. So I2 plus 4. So this can be rearranged as I1 minus I2 is equal to 4. So this can be taken as equation 3. But if you apply KCL to P node, if you prefer to apply KCL to P node, then on that case, this I1 and I3 currents are entering and I2 and I3 are leaving. Similarly, this 4 amps current source current is also leaving. So we can write the equation as I1 plus I3 equal to I2 plus I3 plus 4. So rearranging them, we get it as I1 plus I3 minus I2 minus I3, that is equal to 4. So this I3 get cancelled. So we get it as I1 minus I2 equal to 4. So here also we get the same equation number 3. So either of this method can be applied. Okay. So now we get all these three required equations, equation 1, 2 and 3. So if you look at this equation number 3, it consists of only 2 variables, but equation 1 and 2 consist of 3 variables. So in this I3 is the extra one. So we try to eliminate this I3 variable. Okay, so we are going to use elimination method. For that, multiply this equation 1 by 4, so that you get this as 4I1 plus 24I2 minus 12I3 equal to 16. This becomes your equation number 4. Now we multiply equation 2 by 3. We get it as minus 3I1 minus 6I2 plus 12I3 equal to 0. So that becomes equation number 5. Solving equation 4 and 5, by cancelling this I3, we get it as I1 plus 18I2 equal to 16. So that is our equation number 6. And you bring this equation which we have already, I1 minus I2 equal to 4. So by solving these two, by changing the sign of the third equation, so I1 get cancelled. So you get it as 19 I2, that is equal to 12. I2 equal to 12 by 19, that is equal to I2 equal to 12 by 19, that is equal to 0.6315. So we got the answer for the I2, that is 0.6315 amps. This is answer 2 actually. So now you take again this equation number 3, I1 minus I2 equal to 4, in which you can substitute this I2 value, so that it is I1 minus 0.6315, that is equal to 4. So that we get I1 as 4.6315 amps. This is our answer number 1. Now substitute I1 and I2 answers in equation number 1. We know that equation number 1 is I1 plus 6I2 minus 3I3 equal to 4. So when you substitute I1 and I2 values in that, 4.6315 plus 6 into 0.6315 minus 3 into I3 equal to 4. So that is 4.6315 plus 3.789 minus 3I3 equal to 4. So we get it as 8.4205 minus 3I3 equal to 4. So 3I3 is equal to 4.4205. So I3 is equal to 1.4735 amps. So we get the third answer too. So we got all the three answers. Now we'll verify our answer with the answer given in the book. So it is given as I1 as 4.632, and here we get it as 4.6315. It's okay if you approximate it to the nearest, then we will get it as 4.632. And I2 is given as 631.6 milliamps. Here we got it, we have written it in amps. So if you convert it into milliamps, then you will get the answer as 631.5. It's also good. Then I3 is equal to 1.4736. It is given in the book. We got it as 1.4735 amps. Yeah, we got the answers. Okay, thank you.